we are here with part 2 of PO61, simplifying radical expressions. Here's the thing about radical expressions. In the spirit of Christmas, at least what I said was in the spirit of Christmas, you'll notice that whenever we had fractions in part 1, our denominator was always a perfect square. 16, 121, 25, 64, 49, 4y squared, right? And the reason for that is because it's actually mathematically illegal to leave the root of a non-perfect square in the denominator of a fraction. Because if you think about what a fraction is a part divided by a whole. That whole needs to be a rational number, which the root of non-perfect squares aren't, right? You put the root of any non-perfect square into a calculator and you get the decimal, that goes on forever and ever. So having a non-perfect square in the denominator is a problem, such as 5x over root 7. That would not be considered simplest form because of that root 7 in the denominator of the fraction. So to fix it, we have something called rationalizing the denominator, okay? And what does it mean? Key points, put on a help sheet. The purpose is to make the denominator a rational number. That is, you want to remove the radical, although having a radical in the numerator is okay. To rationalize, here's the key of the key. You multiply the fraction by the radical in the denominator over itself. The radical in the denominator divided by itself. Because what is anything divided by itself? 1. Anything divided by itself is 1. Whether it's a whole number, 5 divided by 5, it's a variable, n divided by n, or something as funky as root 7 divided by root 7. Anything divided by itself equals 1. So when we think about this and we multiply 5x over root 7 by root 7 over root 7, we're really just multiplying by 1. Which means the value of that 5x over root 7 doesn't change. Because whenever you multiply something by 1, the value stays the same. So it's mathematically legal to do this because we're not actually affecting the value of the fraction. What we're doing is affecting how it looks. Because when you multiply fractions, as we know, you multiply straight across, right? And by multiplying this root 7 by root 7, we get the root of 49, which is a perfect square. Okay? So it's a relatively easy process to rationalize. You just have to remember to do it and then do it correctly. Okay? Our numerator changes also because when we multiply 5x by root 7, we do get 5x root 7. We can't combine the 5 and the root 7 because one's under a root, the other one isn't. So you have to keep them separate. And our final answer is going to be 5 root 7 over 7. 5x root 7 over 7. It's okay to have that root 7 in the numerator. It's not in the denominator. And we fix that by multiplying it by itself, giving us a perfect square, and that simplifies to 7. All right, fire your questions at me. Damien.
Could you get arrested for doing math illegally?
Yeah, did you go to math jail?
Math jail, if you want to call that after school working on practice work, yeah, I guess you go to math jail if you didn't do this on a test. Yeah.
No. Can you like if you taught something that was illegal?
Oh, if I taught you to do something that was illegal? Oh, I would never do that.
Yeah, but like you go to jail.
I would not even question. I never do.
Yeah.
Elliot.
So, can you kind of just skip the entire process and just put the root next to the numerator and then take away the root at the top?
Yeah, Elliot's. I assume what you're kind of seeing here is he's saying, folks, multiplying root 7 by root 7, really all that happens is the root just kind of falls off. Yeah. Okay? Which is what happened. Yes, you're absolutely right. If I just did that, I can imagine 30 hands up in the air saying, what kind of sorcery did you just do here? Why can you do that? This is the intermediate step, why it works, But yes, as far as doing the process, you can just kind of understand what happens and go straight from the root 7 to the 7. Okay, where kids fall though, doing that is they forget to put the root 7 in the numerator if they don't show that intermediate step. Okay. Let's look at some of these examples here. 2 over root 3. We cannot leave this as a final answer because we have that root 3 in the denominator. So what are we going to do to rationalize? See, this is why you make me nervous, because I asked the question, and there's one hand in the air right now, 2 hands. Does that mean the others of you don't get it? Or you're just like, oh, sorry,
we're just doing the homework.
Okay. I never quite know how to read that. Ellen, your hand was up first.
Multiply by root 3 over root 3.
Yes. And why doesn't this change the value of the expression?
Because you're multiplying it by 1.
We're multiplying by a really interesting version of 1. Okay? So what does that give us now? In our numerator, 2 times root 3 is 2 root 3. You cannot write that as root 6 because 1 is outside the root, 1 is under the root. They cannot be combined. And then root 3 times root 3 gives us the root of 9, which simplifies to be just 3. So 2 root 3 over 3 would be our final answer. If you wanted to check your answer in a calculator, you can. Take 2 divided by root 3. It's going to be an irrational, nasty decimal. But then take 2 root 3 divided by 3, and it'll be the exact same value. Okay? These values should not change by simplifying. Claire?
Can we do the 2 root 10 over root 80? Yeah.
Hold on. Let's build up to it.
No,
Let's build up. You don't watch the end of the movie first, do
We've
you?
already
No,
We've
you
already
build
seen
up.
the movie. You've already done the first
All right.
We already did the first
Let's look at why we do this, and let's take a look at this one here. Okay, because it might be running through your mind that we're supposed to be simplifying here, but this doesn't look much simpler than my original expression. So what's the point of this? Sometimes you'll run into a term like 12x over root x, where if we are going to simplify this, what do we need to do here to rationalize? Kylie?
Divide both by the root of x.
Yeah. Multiply. Multiply both by the root of x over root of x. That's how it looks. And in our numerator, that gives us a 12x root x. We can't combine our x and root x here because one's under the root, the other one isn't. Okay? So 12x root x. And what does our denominator become? It becomes an x, right? These two multiply to give us the root of x squared, which simplifies to be x. But we're not done. And this is why we rationalize. Because what can we do now to simplify this expression just a little bit further? Liesl? We do have 2 x terms that are both outside the root, right? So they can be canceled out. And so our final expression is 12 root x. Okay? So rationalizing, not only are we ensuring our denominator is a rational number, but we will also get in those situations to where we'll be able to simplify further. Okay? Like in the 2 root 10 over root 80. Let's close with that one. Just by looking at it, what can we do with it first? We've got options here. What do you see, Claire?
Divide by 10 and both the root.
All right, because this root 10 over root 80 are both under a root, we can simplify that. And what would root 10 over root 80 simplify to be? 1 1/8. Just like a fraction, like 10/80ths simplifies to be 1 1/8. Root 10 over root 80 simplifies to be 2 root 1 over root 8. Do we need the root 1? No, because what's the value of root 1? 1. So really, we're already down to just 2 over root 8. We can't simplify the 2 and the root 8 because one's outside the root, one's inside the root. Okay, we could do it here because they were both inside the root. We can simplify our x's here. They're both outside the root. We've got one of each here. So what's our next step? Again, you've got options here. Elliot.
You do 2 to the root 8 over 8.
Okay, so we can go straight to rationalizing here if we want to. We can multiply by root 8 over itself, which gives us what in the numerator? Raise your hand, Aiden.
2 times root 8.
2 root 8. And what in the denominator?
Root 64.
Root 64, which equals 8. Okay? Are we done?
No.
No! What can we do now, Ellen?
You can simplify the 2 and the 8.
We can simplify the 2 and the 8 because they're both outside of the root. And what is the fraction 2/8 simplified to be? 1/4. Do we need to write the 1 in the numerator? No. I will, to start, just so you can see what happened there. 2/8 became 1/4. And then we can simplify this by not writing the 1, and we get root 8 over 4. Are we done?
No.
No! What can we do now? Simplify the root 8 because it contains a perfect square factor. What is root 8 simplified to be?
4.
4 and 2 is the factor pair. And so how's it look? 2 root 2 over 4. Are we done? No! What can we do now? Simplify our 2 and 4 to 1/2, or ultimately 1 root 2 over 2.
We done?
Are we done?
Yes.
Yes, we are. Okay. Yes, we are. So you always have to look for opportunities to simplify. Always be looking for opportunities to simplify. Yes, Ellen.
Could you start by changing the square root of 8?
Yes, you could start way back to the top by simplifying root 80. You could start by, in this step, simplify root 8 there before rationalizing. You've got a lot of different options. The nice part is it doesn't matter what order you do all these things in, as long as you do them all at some point. Okay? Your assignment for tomorrow is just this top section. Don't worry about the bottom. Okay? So the 1, 2, 3, 4, 5 that we did not do. Work must be shown. Okay? Work must be shown. That's how math.